This video will cover activities 23 through 27 in preparation for exam 2 for Math 103 Accelerated. Activity 23 is linear equations in two variables. So here we are taking linear equations in two variables part 1 and extending it to the slope of a line is the ratio of the vertical change to the horizontal change. Change in y divided by change in x, rate of change in y divided by change in x, or denoted by m. I also think of this as up divided by over, or rise divided by run. How far up you go on a line divided by how far over you go on a line. The equation for the slope is the difference in the y values divided by the difference in the x values. So when you have two different points, you have y2, x2, y1, x1, y2 minus y1 divided by x2 minus x1. The order of these 2 points does not matter. All that matters is that if you have y2 and x2, they both come first, or if you have y1 and x1, they both come first. So change in the y value divided by change in the x value. Using that, there are two different ways to get the slope given 2 points. You can either plot those 2 points, so -3, -1 is going to be right down here. +4, +3 is going to be up here. And then you can count your way from one to the other, so you go up by 1, 2, 3, 4, and over by 7 to get a slope of 4 over 7, or you can do the subtraction. 3 minus a -1, be very careful about the negative signs in this, divided by 4 minus a -3. 3 minus -1 is the same thing as 3 plus 1, which is 4. 4 minus -3 is the same thing as 4 plus 3, which is 7. Two ways to get the same slope. The reason that we want to use the equation is because simply it's faster and more accurate than trying to put in 2 points and count the distance, especially if those 2 points are not on nice even numbers or if they're very far apart. Positive slope means that your line is increasing. Looks like this. Negative slope means that your line is going down. Both of those are perfectly fine to have. That's just the meaning of them. There are a few different equations that we use when we're talking about lines. The most common is the slope-intercept form, y equals mx plus b. Here, m is the slope, and b is the y-intercept. So when we're given this form, we can graph it really easily by putting in that -3 on the y-intercept, and then counting the slope. So the slope is rise over run. That says you go up by 2, 1, 2, and over by 5, 1, 2, 3, 4, 5, to get to right here. That's your second point, and then your line goes right through those 2 points. Over here, it's not in the slope-intercept form yet, so we need to solve this. 3y equals -2x plus 6, just subtracting that 2x from both sides. Divide by 3 to get y on its own. That says that y is equal to -2/3 x plus 2. Here we have a slope of -2/3 and an intercept of +2. So you go up to +2, and then negative slope means that you go down instead of up, so down by 2, and then over by 3 to get your second point right there. Your line goes through both of those. Like that. Moving on from there, point-slope formula of a line is when you do not have the intercept. This is when you're given the slope and one other point, or when you're given 2 points. So this question right here says find the equation of the line given these 2 points. So for the point slope, you need the slope, and you need 1 point. Here we have 2 points, so the first thing we need to do is find the slope. Slope is equals to the change in y divided by the change in x. If we plug in those numbers, we get this. change in y values divided by the change in x values. So we have a slope of negative 4/3. Then you take that slope and the point and you plug those in. Y minus y1, x minus x1. And it does not matter which one of these points you use. In this case, I used 1, 1, simply because they're smaller numbers and nicer to plug in. So add the 1 to both sides, and here's what you get. 4/3 plus 1. Again, to add together fractions, 4/3 plus 1. Get the common denominator, change that 1 to a 3/3. 4/3 plus 3/3 is equal to 7/3. So this becomes y equals negative 4/3 x plus 7/3. This tells us we have an intercept of 7/3 and a slope of negative 4/3. Quick piece about horizontal and vertical lines. Equation of a horizontal line containing that point is just the y coordinate of that, y equals the y coordinate. Equation of a vertical line is x equals the x coordinate. So, write an equation of the horizontal line containing this point, y equals negative 6. Write an equation of the vertical line containing this point, x equals positive 3. For the activity, it's just a lot of practice problems with those, so I will work through a few random ones. Determine the slope of each line given 2 points on that line. Negative 4, negative 1, and negative 4, positive 3. Those are the 2 points. This is what our line's going to look like. Slope, that's a change in the y value, divided by the change in x value. That gives us 4 divided by 0. Cannot divide by 0, so that has an undefined slope. Which is saying whenever you go up, you don't go over at all. So there isn't any way to define that slope. When you have a vertical line, you'll always have an undefined slope. This one right here will have a horizontal line that has a slope of 0. I'm not going to go through the work for that. Let's do one of these. Equation to determine the slope. We have positive 4, negative 3, negative 8, positive 5. Right there. So we're going to have a negative slope on these. I don't want to count the distance between them, so let's subtract. Using the equation, m is equal to 5 minus negative 3 divided by negative 8 minus 4. That's equal to 8 divided by negative 12, which, if we simplify that, we can take a 4 out of both of those, is equal to negative 2/3. This says graph each line given its slope and 1 point on the line. Point 12, slope of negative 4. Whenever you've got a whole number for a slope, think of that whole number as being divided by 1. So that way you get into the form of rise over run. 1, 2, x is 1, y is 2. Slope of negative 4, you go down by 4, over by 1. So that's our second point. You get this very steep line right here. Graphing these lines, graph each line using its slope and y-intercept. Solve it into y equals mx plus b form. Nine over 3 is 3. So that says we have a slope of negative 1/3 and an intercept of positive 3. Intercept of positive 3, slope of negative, go down by 1/3, go over by 3. There's your second point. And then you draw a straight-ish line through those 2 points. If your line isn't perfectly straight, you can also make the points bigger to include your line. Then we have a few word problems back here. Find the equation of a line with a slope negative 5.13. All of this is about plugging it into the appropriate equation. If we're given a slope and a point, you plug in to the y minus y1 equals m times x minus x1. So that gives us y minus 3 equals negative 5 x minus 1. And then if you're only told to find the equation, that's the equation. If you're told to write it in standard form, in slope-intercept, in whatever form, then you have to do some algebra to it. Down here, if you're given 2 points, you first have to find the slope, change in y, over change in x, 4 over 4, slope of 1. And then plug that and one of the points into the equation, y minus y1 equals slope times x minus x1. Y minus 2 equals x plus 1. And again, it doesn't matter which point you use for your x1, y1, and which for your x2, y2. All that matters is that you're consistent about which one comes first. And same thing down here. It doesn't matter which one of those points you use, so long as you plug them into the right parts. Next activity is linear equations in two variables and applications. So this adds on word problems, and it adds on parallel and perpendicular lines. Parallel lines have the same slope, but different y-intercepts. Perpendicular lines have slopes that are negative reciprocals of each other. So reciprocal means that you flip it over. You can also think of this as negative inverses if you're more comfortable with inverses instead of reciprocals. Inverse comes from the same word as invert, which means to flip over. So inverted and have a negative sign stuck on them. So to determine whether a pair of lines are parallel, perpendicular, or neither, that is an option. First, you put them into slope-intercept form. So here we have y equals 6x minus 9. That's already in the correct form of y equals mx plus b. This one we need to solve. So that gives us a 6y equals negative x plus 12. Divide by 6. Y equals negative 1/6. X plus 12 over 6 is 2. So one has a slope of 6. The other one has a slope of negative 1/6. If we take 6, we take the inverse of it, that's 1/6, and then we make that negative, we get negative 1/6, which is the second slope that we have. That shows that 6 is the negative inverse, or the negative reciprocal, of negative 1/6. So that means that they are perpendicular. One other thing is if you have a vertical line and a horizontal line, they're guaranteed to be perpendicular. So if we graph these, let's look at what's going on here. X equals negative 4. Y equals 11. Y equals 11 is a horizontal line, like that. X equals negative 4 is a vertical line, like that. Perpendicular means that they have right angles between them. It's a horizontal line, it's a vertical line, it's guaranteed to be perpendicular. Then we have these long problems where it gives us an initial line, asks what the slope is, to determine the equation, all of that stuff. So line x minus 2y equals 8. Solve that real quick in two-point slope formula, or slope-intercept, excuse me. Subtract x, that gives us negative 2y equals negative x plus 8. Divide everything by negative 2. That gives us y equals negative x divided by negative 2 is a positive 1/2 x. Positive 8 divided by negative 2 is negative 4. And that tells us our slope is 1/2. So m equals 1/2. Determine the equation of a line that is parallel to this. Well, if it's parallel, then it has the same slope. You have slope, you have a point. You use the point slope formula. Y minus y1 equals m times x minus x1. Y minus 3 equals 1/2 x minus 1. That's an equation for it. If we don't have to graph it, that's all we'll need to do. But later on it says graph it. So let's solve this into the slope and intercept form. Distribute that 1/2. We get y equals 1/2 x minus 1/2 plus 3 by adding the 3 over to the other side. Negative 1/2 plus 3. Get the common denominator, that's negative 1/2 plus 6/2, because 3 is 6 over 2. Negative 1 plus 6 is positive 5. So that's 5/2. That tells us that our equation is y equals 1/2 x, slope of 1/2, plus 5/2, intercept of 5/2. Next part, determine the equation of a line that is perpendicular. Perpendicular has negative reciprocal, or negative inverse slope. So you take that 1/2, you flip it over into positive 2, and then you make it negative. You get negative 2 for the slope. So m is equal to negative 2. And then everything else is exactly the same. Y minus 3 equals now negative 2 slope, x minus 1. Solve that through, distribute all of that stuff. Y equals negative 2x plus 2 plus another 3. So there are our equations. Then it says graph these lines. So the first thing we have to graph is y equals 1/2 x minus 4. We have an intercept of negative 4, slope of 1/2, so up 1 over 2, goes through those points. Your lines don't have to be pretty, they just have to be accurate. Up here, this equation is y equals 1/2 x plus 5/2. 5/2 is the same thing as 2 and 1/2. So you go to 2 and you go up by another 1/2. And then same slope, up 1 over 2 through these points. About like that. So there are our two lines, and then finally it says determine the equation of a line that is perpendicular to that passes through the point 1, 3. So it'll also go through this point. The equation is y equals negative 2x plus 5. So we go to 5 and negative 2x as we go down 2 over 1. We get a line that looks like that. It's at right angles to this line. It's at right angles to this line. So it's perpendicular to both of those. Goes through the correct point. All the information that we needed. Moving on from there, we also have these word problems. We have equations. We have to interpret them. All the equations are linear. Pay attention to the units on these equations when you're solving them. Here, for instance, determine the linear equation modeling this, or the value v of the coin in terms of time. So whenever we have time, time will always be progressing horizontally. Time is always going to be your x-axis. Your other thing in this case, value, is going to be your y-axis. This is that in year 1988, and it says let t equals 0 correspond to year 1988. So right here, 0 equals 1988. Your time in years is equal to 0. Your money, your value, is equal to 150. And from there it increases, and so we're just going to be writing an increasing line that's straight. Well, we have an intercept. We just need the slope. Slope is the change in value divided by the change in time. That's equal to 40 over 16, which can be simplified down to 5 divided by 2. That's going to be dollars per year. What does the slope represent in this context? Be specific to this problem. Well, the slope is in dollars per year, so it goes up by $5 every 2 years. The value increases by $5 every 2 years. Or another way you can think about this is as 5 halves of a dollar every year. That's the meaning of the slope. And I just got that from the context of the units on these. The value is in dollars, so we're looking at the change in dollars divided by the change in years. Dollars per year. How much was it worth in 2014? This is 10 years past 2004, so this is, instead of year 16, it's going to be year 26. So your time is 26. And I just realized we didn't actually find the equation back here. So let's go back and do that. The value, y equals mx, m is 5 halves, time plus the intercept of 150. That's using y equals mx plus b, except for we're using v and t instead of y and x. So time equals 26, so v equals 5 halves times 26 plus 150. 5 halves times 26, 5 times 26 is 130, divided by 2 is 65. So this is 65 plus 150, which is equal to 215. So $215. In what year is the penny worth $300? So here the value, that's a unit of money. Value, the v variable, is money. And we're solving for time. So here we put in 300 for v, and you solve for t. So I subtracted 150 over to the other side to get 5 halves t is equal to 150. Then I multiplied by the reciprocal of 5 halves, which is 2/5, to get t equals 2/5 times 150. 150 divided by 5 is 30. 2 times 30 is 60. So 60 years. That's your answer. From there we have activity 25, which is quadratic equations. Quadratic equations go back to activities 9 and 10, where we learned to factor quadratic equations first. To solve quadratic equations, the most important part is the zero product rule. The zero product rule states that if the product of two quantities is 0, then one or both of the quantities must be 0. So if you have a quadratic in factored form, you can just set each piece equal to 0 in order to solve for the variable. So an equation like this, when you have 4y minus 3 times y plus 9 equals 0, all you have to do is say either 4y minus 3 equals 0, or y plus 9 equals 0. Subtracting 9 from both sides here, we get y equals negative 9. Up here, you add 3 to both sides, divide by 4, to get y is equal to positive 3 divided by 4. So your solutions are negative 9 and 3/4. That works great if you already have a polynomial factored. If you don't, however, you need to go through different methods of factoring. Here we can use the sum product rule, which says look for two things that multiply to equal this term, add to equal this term. Two things that multiply to equal negative 40, add to negative 6. So you look at all the factors of 40, 1 and 40, 2 and 20, 3 isn't a factor, 4 and 10, 5 and 8. and you're looking for two that add to equal to negative 6. Multiply to a negative number, so one of them has to be negative. Add to a negative number, so the bigger one has to be negative. 1 minus 40 is negative 39, 2 minus 20 is negative 18, 4 minus 10 is negative 6. That's the one that we're looking for. So this says that the factorization is simply m plus 4 times m minus 10. And if you multiply this back out, you would see 4 times negative 10 gives us the negative 40. M times negative 10 plus 4 times m would give us the negative 6m. This right here is equal to 0. So that means that each one of these terms, m plus 4 equals 0, or m minus 10 equals 0, which means m is equal to negative 4 or positive 10. That is essentially what this entire activity is simply factoring polynomials and setting the individual pieces equal to 0. For more practice of this, you can also go back to activities 9 and 10 and review factoring there. Activity 26 is quadratic equations and applications. So this takes the quadratics and adds word problems. This is a refresher of the steps for solving application problems. So read the problem carefully. Make sure that you understand what the problem is asking for. Read the problem as many times as needed. Then you choose a variable to represent the unknown quantity. Define each unknown in terms of the same variable. Step 3 is translate the problem from English into an equation using this variable. Solve the equation, then check the answer and interpret the solution. At this point also, it doesn't say this here, but reread the problem after you've solved the problem to make sure that you actually solved what the problem is asking for. So here's an example of one of the problems. An object is launched with an initial velocity of 96 feet per second. The height of the object, h in feet, at time t seconds, is given by h equals negative 16t squared plus 96t. So we're given an equation. H is height, t is seconds. It says from what height is the object launched. Interpret each one of these pieces. What height is the object launched? That's solving for h, given a t. Well, what time would you launch it at? When would you start the clock? This right here is t equals 0. Plug in 0 for all the t's, solve for h. Find what the h value is, find what the height is. How high is the object after 3 seconds? Seconds, that's time. Time t equals 3. How high is the object? That says find the height, find h. Object reach a height of 128 feet. This says the height is 128. When? That's units of time. Find t. When does the object hit the ground? That's asking find t. Does the object hit the ground? The ground, generally we consider the ground to have a height of 0. H equals 0. Plug in 0, find t. Plug in 128, find t. Plug in t equals 3, find h. Plug in t equals 0, find h. These two, it says use the Pythagorean theorem on this to set up an equation relating sides of these triangles. This problem doesn't say anything about the Pythagorean theorem, but that is exactly what it is. You have a wall. You have a ladder. The ladder is leaning against the wall. The ladder is 13 feet long. The distance from the top of the ladder to the bottom of the wall, top of the ladder to the bottom of the wall, is 7 feet more than the distance from the bottom of the ladder to the wall. Distance from the bottom of the ladder to the wall, 7 feet more than the distance from the bottom of the ladder to the wall. Here we have a triangle, right triangle. We have the sides of it, so it is a Pythagorean theorem problem. A squared plus b squared, the two short sides, is equal to c squared, the long side. Takes both of the short sides to make up the long side. This gives us x squared plus x plus 7 squared equals 13 squared. And then you work through and solve this. Get everything onto one side by subtracting that 169 over here, combine like terms, and then factor. Here I factored out a 2 because that's common to everything, and then we can use the sum product rule to look for two things that multiply to negative 60 and add to positive 7. So we're looking for two numbers that add to a positive number, multiply to a negative number. That means that the larger one is positive, the smaller one is negative. Factors of 60, 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12. Smaller one is negative, larger one is positive. We add these together, and there we have it. Negative 5, positive 12, add together to positive 7, multiply together to equal negative 60. Factor this then, and we get that. That says that x equals 5 or x equals negative 12. Which one of those is the answer? Are both of those the answer? Well, here we have a real world problem, and here we have a negative distance. Negative distances do not exist in the real world. So our only solution is x equals positive 5. And that right there, it says determine the distance between the bottom of the ladder and the wall, right there to right there. So distance of 5 feet. We have a few problems on the back. Product of two consecutive even integers. Somebody build a rectangular raised garden bed to grow vegetables. Whenever you can, draw a picture. So rectangle, there's a rectangle. Area of 24 square feet. The length of the bed is 2 feet longer than its width. So let's make the longer side be the length, make the shorter side be the width. Length is 2 feet longer than the width. Length is width plus 2. The product of these two gives us the area. W times W plus 2 equals 24. Then solve that. This one, stained glass windows to sell at crafting events. For one pattern, they have a rectangular piece of glass which is 3 inches wider than it is long. Rectangle, area of the glass is 54 square inches. And they want to find out what the perimeter is. 3 inches wider than it is long. So this should be the length. This should be the width because it's wider than it is long. Width is length plus 3 inches. So length times length plus 3 equals 54. And then find that. So find 2L plus 2W. So you solve for L and then plug that in here to find 2L plus 2 times the width. And that's the perimeter. The final activity for this exam is activity 27, which is radical equations. Radicals, again, are roots. We haven't talked about them for a while. Here are the steps for solving radical equations. Step 1, you get the root, by itself on one side. Then you square both sides to get rid of the root. Combine like terms on each side of the equation. And then if you still have radicals, repeat that process until you don't have them anymore. Then, at this point, you should solve the equation and check the proposed solutions in the original equation, make sure that they work. So here, step 1, so you get the radical on its own on the side of the equation. So you get negative square root of 8u minus 12 is equal to negative u. Step 2 is you square everything. Square this side, we get 8u minus 12 is square this side equals u squared. Subtract u squared back to this side, negative u squared plus 8u minus 12 equals 0. I don't like that negative there, so I'm going to multiply everything by negative 1. That gives us u squared minus 8u plus 12 equals 0. So we're looking for two things to multiply to equal 12, add to negative 8. So if they're multiplying to a positive number, adding to a negative number, they have to both be negative. So options for this, 12 is 1 times 12, 2 times 6. I think we got it right there, because they're both negative. Negative 2, negative 6 adds to negative 8. That means that this factors into u minus 2, u minus 6. That tells us that u is equal to positive 2 or positive 6. Then I test both of these numbers back up here. 2 minus square root of 8 times 2 minus 12 equals 0. 8 times 2 is 16 minus 4, or minus 12 is positive 4. So that's 2 minus the square root of 4 equals 0. 2 minus 2 equals 0. That's correct. So this one works. Or positive 6. Test that one. 6 minus square root. 8 times 6 is 54. Or 48, excuse me. 8 times 6 is 48. 48 minus 12 equals 0. 6 minus square root of 36 equals 0. 6 minus 6 equals 0. That works. So both of those are solutions. You have to go through the checking process to make sure that they're correct. I'll just work through a few more examples here. Isolate the root. Square it. Get everything onto one side of the equation. 9 minus 5 is 4. Negative 6x plus x is negative 5x. And then factor this. Two things that multiply to 4 add to negative 5. They both have to be negative. So that should be negative 4 and negative 1. That says that x equals 1 or 4. Then check both of those. Square root of 5 minus 1 is square root of 4, which is 2. 1 minus 2 does not equal 3. So that's not a solution. Then or positive 4. 4 is a solution. So x equals 4 is the only solution. Isolate a radical. Here we have 2, so we have to isolate one of them. I'm going to do the square root of x plus 5. Square both sides. We still have a root, so we need to isolate that again. We subtract x from both sides. X minus x is 0. 5 minus 25 is negative 20. That means that square root of x is equal to positive 2. Square both sides. That tells us x is equal to 4. Check your solution. And it is an actual solution. So that's the process for solving those, and that is the end of activity 27. The only other problem is here where you have a cubed root. In this case, you cube it instead of squaring it. That's the end of the review for the exam. Best of luck on the exam.